we will discuss question by question. Okay, some sample questions like let us suppose you are having instruction pipelining. What type of questions are coming in the instruction pipelining? So let us take the sample question is one of the previous gate question. The instruction pipeline of a RISC processor has the following stages: IF, ID, OF, PO and WB. IF indicates instruction fetch, ID is the instruction decode, OF is the operand fetch, PO is the perform operation, that is nothing but execution of instruction, and WB is a write back stage. And the IF, ID, OF and WB stages take only one clock cycle each for every instruction. Consider a sequence of 100 instructions. In PO stage, 40 instructions take 3 clock cycles and 35 instructions take 2 clock cycles, and remaining 25 instructions take 1 clock cycle. Assume that there are no data hazards and no control hazards. The number of clock cycles required for completion of execution of the sequence of instructions is dash. So there are 3 categories of instructions. Okay, 40 instructions take 3 clock cycles. Okay, 35 instructions take 2 clock cycles in the PO stage, and 25 instructions take 1 clock cycle. So now we need to discuss the total number of clock cycles required for this. Here RISC indicates reduced instruction set computer. Reduced instruction set computer. That means a limited number of instructions are being used for the execution of instructions. Okay. So the format of instruction is also of uniform length, and a limited number of addressing modes will be used in the RISC operations. Okay. There are 2 categories of operations like RISC and CISC operations: reduced instruction set computers and complex instruction set computers. Okay. So the instruction pipeline of RISC, as mentioned, there are 5 stages. Okay. So there are 5 stages. It is mentioned each stage about the number of clock cycles required. So IF, ID, OF, PO and WB stages. Okay. Now let us see the clock cycles required. Let us suppose you are taking the clocks like this. So clock cycle 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and so on. So we can't show for all the 100 instructions, just we have to make an assumption, and accordingly we have to calculate the total number of instructions and clock cycles required. Okay. For example, for the first instruction, let us take 40 instructions. So 40 plus 35, it is 75 plus 25, total 100 instructions. So first 40 instructions take 3 clock cycles for the PO stage, remaining all 1 cycle only. So IF, ID, OF and also WB takes 1 cycle, and this is taking different number of cycles. Okay. So now we can take this instruction fetch here, IF, followed by ID, that is instruction decode, followed by operand fetch, then followed by perform operation. Perform operation takes 3 cycles, PO, 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 followed by WB stage. This is for the first instruction. So if you go with the next instruction, as he mentioned, there is no control hazard, there is no data hazard. Hazard is nothing but strucking, instruction may be getting struck because of different reasons. Maybe data required from the previous instruction, or maybe same resources are used, or maybe present instruction is a branch instruction, etc. Okay. Now we can do the IF here, because same stage cannot be done in same cycle for multiple instructions. Then we can do the ID here, and we can do the operand fetch, and perform operation we can't do here. So we can do perform operation, because 3 clock cycles are required, then followed by WB. So if you see, after 7th clock cycle, first instruction got finished, then if you wait for 3 more clock cycles, second instruction will finish. Like that 3 cycles you have to wait. So that means what happens for 40 instructions? Okay, first instruction will be 7, so remaining 39 instruction, so 39 into 3 cycles will increase. Okay, similarly, maybe after 40 instructions, that is I40, then there will be 35 instructions take 2 clock cycle each for the PO stage. Say for example, if you take I41, so I41 maybe instruction fetch if you do here, okay, instruction decode if you do here, okay, operand fetch if you do here, perform operation can't be done here, here we can do PO, PO and then WB stage. So 2 cycles extra, because that is also being done parallelly, because in a single cycle multiple stages will be overlapped. Okay. So because of that, from 41 to 75. So these are from instruction I1 to I40. This is the scenario. Similarly, instructions from I41 to I75. So there are 35 instructions. Take 2 clock cycles. That means, so it will be 2 into 35 instructions. So what is this calculation? This calculation is 39 into 3. So what is its value? 90 plus 27, 117, 39 into 3. It is 27, 117 plus 7. So it is 124. 124 is the total number of clock cycles taken for the first 40 instructions, and 2 into 35, it is 70. It is for remaining instructions. Then there are last 25 instruction now, 111 will be increased, because we can do instruction fetch here, instruction decode here, okay, operand fetch here, perform operation can be done here, because only one clock cycle write back. So 1 cycle will increase. So it means that there are 25 cycles. So for the instructions from I76 to I100, so there will be 25 cycles. So 124 plus 70, 124 plus 70 plus 25. So this will be 9, okay, and 9 plus 2, 11. So 219. Total number of clock cycles taken will be 219. So this will be the correct numerical answer for it. So this is asked for, this is a 2-mark question in one of the previous gate. So this type of question will be asked.